Hello Internet, this is JF, and I suck at ATS. Let's test and see if a file exists. So I was rewriting a program recently in ATS, and one of the things it does, the whole program is gated on a particular proc file existing, like under the proc file system. Because if it doesn't exist, it'll just say, "Oh, you don't have the right version of Linux, you don't have the right feature of Linux, whatever." Okay, so that program will definitely come up in the future, but for now, let's just use stat. Okay. So these are the stat syscalls under Linux. So we've got the stat, fstat, lstat, and statat. So what we need just to say, like, if all we're interested in is, well, something like what this program is doing was saying, if you don't have this proc file, then you're not going to be able to run the rest of the program. So just give up now. For that, it's fine just to use stat. You give the full path to that particular file. Uh, but normally, if you might want to use one of these other things, like if you're gonna say, should I open this file or do something with it? It's better to open it and then do an fstat on the thing you opened. Or there are lots of things to think about like that. Like you want to be precise when you're dealing with the file system and permissions and things like that. Like if you can use it, you want to avoid like lstat and so on. And also like one reason to use open to begin with is open has a lot of extra flags. So you can use it for Linux to say like don't open a directory, or don't open if it's not a directory, or do things like that. And you can open directories. Like with the open syscall, open a directory and then, of course, not read from it since it's a directory. But you can pass the FD you get from it, the file handle you get, to stuff like this. So you can say, now that I've opened this directory, I want to look at a file relative to the directory. I want to look at a file just inside the directory, regardless of what happens to that directory while I'm looking. So there can be all kinds of shenanigans under Linux, like the usual like race condition suspects of you stat something and then you try to open it, and then between the stat and the open, the thing changes. But also directories can move around and so on. So Linux has like lots of features to deal with that. Like one of my favorites is rename at the rename at syscall, because if you use rename at 2 with flags, then you have this option: rename at exchange, atomically exchanged both of the paths. So you can just swap the position of two files atomically, so it's not possible for somebody to interfere with that, or actually you can't accidentally destroy one of the files or duplicate it or anything like that. So there's lots of stuff that's sort of gated away by being just being C and C. Like you have to have something that works well with C in order to use it. Because even though there are lots of languages, there are lots of languages that try to make this stuff easy. Like scripting languages, they're all from 15 years ago, and they stick with those features. So like Perl or Python or something, you generally don't find like rename at 2 syscalls, like the stuff like that, or the statat, or any of the at syscalls. Like just pretend they don't exist, because even though Linux has been evolving since 15 years ago, the scripting languages just don't. And also they're like, oh, we gotta be portable, and like, okay, well that just means you don't have features that people can use you for. So anyway, what we're gonna do now is just stat a file using this one stats call, see if it exists or not. So it's pretty straightforward. Extern fun stat. Takes a string and a buffer. I on a previous take of this video, I confirmed that no, you can't send it. You can't give it a null pointer. It'll just fail with an ebad, not ebadf, but efault. So bad address. If you give it a bad address for the struct stat, it'll just fail. So it won't actually stat. Okay. So string, let's make a type def of this struct stat thing and call it statbuff. So ext type, xx type, not ext type, not external type. No, it's x type, like that. Struct stat. So we're going to take a reference to an uninitialized stat buff, and we're going to turn that into a stat buff. Basically, give it a pointer to something sized. Give it a pointer with this type, to it, and it'll populate that pointer with a stat buff, which is in fact exactly what the thing does, and returns an int. Of course, in order to use that, we need to have these includes. And that should be all that we need. So fun exists with a path, return a bool, and we're just going to say, so we're making a stack allocated variable here. We use it with var, and we're going to call it buff. It's of type stat buff. We don't initialize it or anything, and then we run stat against it. And that will initialize it if this succeeds. That's one thing I'm a little bit concerned about. Like, I should probably use like refinement types to like tie this int together with this, so that it's not possible to try and use stat buff as initialized if this doesn't return true. But I'm not quite sure how to do that. I'm still treating like this construct right here as kind of magic. So I need to do it like have it actually return like an L or something, or do something. There's more that needs to be done with this type in order for it to be perfectly good. Right now, it's still pretty good. So you just don't use buff unless stat returns success. Okay, so if res equals 0, so it's not an error, then that's it. That's in fact it. We don't actually care about buff. We don't care about anything it puts there. We just care about whether the stat succeeded. And if it succeeded, that means the file exists. Okay, so put mine. Okay. So etc password exists. And let's go ahead and trace that. Yeah, it does a stat. It's successful, and it returns all this information. And I'm not sure why there's an F stat there. That's probably part of the runtime. All right, let's make this something that doesn't exist. And that not exists. Excellent. So there you go. If you want to test and see if a particular path exists, then you can just you map cstat and then use a stack allocated buffer for the stat information that you don't care about, and just pass that to it. And this is all fine. But let's say you don't just want to do just that one thing. Let's say you actually want to do something with the stat buff. So there's a lot of questions you can ask about a file. You can say are you a directory? Are you a symlink? How old are you? And a lot of information in this buffer. So yeah, it has it has owner information, it has size information, all kinds of stuff. It has access information. So you could have multiple functions that say exists or is readable or that kind of stuff, and pass a path to each of them, so each of them have to stat the same file over and over again. Or you could give this, instead of using a throwaway stat buff, you can actually return the stat buff and then have functions that test that. Which seems like a more reasonable way to go. But then how do you give a lifetime to this weird type? This is an external type. It's like a struct stat. So how do you give a lifetime to that that's reasonable? So I guess there are two ways. One way is you say data type. So ML style data type, you say stat buff or whatever. You can do it however you like. And then you can create one of these. So you'd say, okay, var stat buff, now I want to return a stat. and then this would return a stat buff in that case, and then it would be garbage collected eventually. But let's not use the garbage collector. Let's use a linear object instead, because it seems like a stat buff. You want to, you're not like. Why would you want to like duplicate it or do any weird stuff? Just you create it. You ask a bunch of questions on it, and then you throw it away. So let's use linear types because they model that pretty well. So data v type, data v type, like that. We're going to call it stat buff vt, and then stat buff. So now we're going to say, let's rename this one to cstat. So cstat, we're not going to call that directly anymore. Now we're going to have our own interface, which you might want to do anyway because, like I said, the type isn't quite right on this. So hiding that helps. So funstat, and takes a path, and returns a stat buff vt. Actually, we should probably make it an option. Option stat buff vt. Okay, so let's create a stat with a hole, val, having like a moment of confusion. I want to create a stat with a hole, and I want to populate the hole. So I got to give it a name. What am I blanking on here? Buff. Okay, here we go. Yeah, so buff equals stat with a hole. And then we want to name the hole so that we can populate it. I could say valres equals cstat with the path and the hole, so it populates this, and so this linear object now has stat buff information on it. Then because we're using holes, we had to say that this is now legit. We're now looking at modifying it. All right. So if res if returns 0, then we'll do like some vt buff. So we're returning the stat buff now. But if res isn't 0, then we need to do a little bit more. We can't just say else none vt because we still have this linear object we have to deal with. So let's do it like this. Let's say none vt where. We just clean up the stat. This is again the tilde of destruction that frees up. It's pattern matching with freeing. So we're just going to go ahead and get rid of it now. All right, that seems like it works. So let's ask a question about it. So not just say whether something exists, but let's start mapping some of these questions. So fortunately, C has some macros. And again, normally these macros would be of no use to you, but since ATS has such a good interaction with C, you can actually just directly use these. So let's say extern fun s is dir. And that works on the st mode, so it's like an int. And then, of course, we have to get the st mode, unfortunately. Let's actually use a macro for that. Okay. So now if we have something like fun is dir, and then a stat buff. Of course, we have to borrow it. We don't want to consume it. So we want to ask multiple questions. So is dir returns a bool, and what is this? Stat mode of. No, you got to match it first. So let's. Stat mode of buff, and s is dir. And let's say is reg as well. Now this obviously seems like some redundant code, so maybe using the macros isn't quite so good. Some other way to do this, but for now, like this is just examples of code. So I'm gonna go ahead and just copy and paste this. Just say isreg, isreg. All right, so I've got a path. We get stat information. So val. Let's make it a runtime error if it fails to stat. So it'll always so stat buff equals. This is a little bit odd. Like so, like if you were pattern matching buff out of it. So if, like before, when we had linear objects that were wrapped around tuples, when we pattern match part of the tuples out, obviously the parts we matched out like continued to be available, and I think that's also the case here. Like it creates like a local struct when we do this. So this is also like a stack allocated variable just for the buff now that we match it. So I think we can throw away the linear object at this point. But I'm not too clear on how exactly this works, so I asked a question about it on Stack Overflow, but I haven't gotten an answer yet. So it's a runtime error if this doesn't match. So sum vt. So I'm going to throw away the sum vt and throw away the stat. I want to keep the buff. All right. And then we'll say whether or not it's a directory or not. So isreg. It's a directory. We'll do it like this, an if case. Is there? We know it exists because otherwise that'll be a runtime error. Constructor stat needs no indexes, but given some. Oh yeah, this is a stat of stat buff. It's not refined by stat buff. Dynamic identifier s is reg. I'm going to map that as well. Dynamic expression cannot be assigned this type stat buff underbar vt. It's on line 50. Oh, we're passing this to a path. Yeah, obviously that's nuts. But also, we're passing around the stat buff, not just that buff information. Okay, so we can't actually do this. We'll throw away the sum, but we'll keep the stat for now. So just say stat buff. And then we can have it be borrowed by that. Now I'm wondering, like, could I just pass like buff directly to these, like stat buff rather than stat buff vt? I'm not sure how exactly does that work. Like, is it passing like a pointer to a struct? Or I think that would be the case. But anyway, we definitely need to free this then. Let's try and just free a stat buff at the end. Cannot be resolved. Doesn't actually like that. Okay. How about that? Oh, okay, so it's not complaining that we're not telling it how to malloc stuff. So let's move file exists.dats, file exists.lc.dat or lc.dats. So my make file looks for things that end in a name like lc or gc, and it adds the appropriate flag. So we don't need this anymore. We don't need this anymore. There you go, see it. ATS memalloc libc. All right, so EC password is a directory. I don't think it is. Oh, hold on. There we go. Oh, look at this. That is a bug that ATS cannot save you from. All right, so etc password is a regular file. Now let's say etc itself. That's a directory. All right, so it seems like that all works. So instead of having a stack allocated variable like we did originally, we're populating a linear object we then pass around, and then we ultimately free at the end with destructive pattern matching. So this is a little bit weird. Probably going to return. We're definitely going to return to these kind of subjects in the future. But for now, that's the video.